Hi grade 12s, welcome back to my channel. It's Maths and Science with C once again, and on our previous video I had mentioned that the next video we will be doing questions on calculus. So I have, most of you are writing tomorrow and Monday, so I have a June examination, grade 12 2023, and from this paper we are going to tackle that calculus section. So bear with me and let us get to it. Okay, so starting with question 6. Question 6, we have given f at x is 3x minus x squared. Use the definition from first principles of the derivative to calculate f prime x. So we need to derive using first principles. So we know, guys, with first principles, I'm just gonna scroll a bit up. With first principles, we know we make use of f at prime x equals to the limit as h tends to be 0, where we have f at x plus h minus f at x all divided by h. So starting with our f at x plus h, f at x plus h would be, remember where you see x, you're going to put x plus h. So we have 3x plus h minus x plus h squared. So that would now be 3x plus 3h minus x squared plus 2xh plus h squared. And as a result, we have 3x plus 3h minus x squared minus 2xh minus h squared. So now we are going to go back to our f at x formula. So we had set the limit as h tends to be 0, and our f at x is 3x plus 3h minus x squared minus 2x minus h squared minus, which is that minus over there, our f at x, which is the original graph itself, that's 3x minus x squared, all divided by h. And when we remove that bracket over there, the limit, as remember guys, you are carrying the limit as h tends to be 0 throughout, and until just before you substitute your 0 for h. 3h minus x squared minus 2x minus h squared minus 3x plus x squared, all still divided by our h. Now I'm going to look for our like terms. Our 3x is going to subtract with the negative 3x, and our negative x squared is going to subtract with positive x squared. So as a result, the limit as h tends to be 0, we are left with 3h minus, sorry guys, I omitted an h there, minus 2xh minus h squared, all divided by h. And the limit as h tends to be 0, I'm going to take out h as a common factor. So taking out h inside of the bracket, I'm left with 3 minus 2x minus h, all divided by h. And remember that h is going to cancel that one, and we still say the limit as h tends to be 0, it's 3 minus 2x minus h. Then when we after we substitute 0 for h, you're going to have f prime x is equals to 3 minus 2x, and that is our final answer. We can also go up there to prove it. Remember, if you have 3x minus x squared, also when you derive it using normal derivative methods, you'd say 1 minus 3, I mean 1 multiplied by 3 is 3, 1 minus 1 is 0, x to the power of 0 is 1, and then we drop the 2 there, x. So we have proven that our answer is indeed correct. So this step is not necessary for you to write it as part of your answer. You'll just write it to the side when you're writing an exam to test if what you have gotten from first principles is that, and then you can be sure that your answer is correct. Okay, so that is 6.1, and then now starting with 6.2, I'm just gonna erase that part over there. 6.2, determine dy dx if y equals to x minus 3 square root of x over x squared. So remember, firstly, before you can derive, your x must never be a denominator, and you don't want to have a third or a square root, meaning we're going to have y equals to x minus 3. Remember, in order for us to remove a square root, we remove it with a half. So the x gets an exponent of a half over x to the power of 2. And then the next thing, I'm going to separate x over x to the power of 2 minus 3x to the power of a half over x to the power of 2. So there we have 1 minus 2, that's x to the power negative 1, and then 3, and then x1 over 2 minus a 2 1 over 2 minus a 2, that should be negative 3 over 2. So that is 3x negative 3 over 2. Then now we can start deriving. So we go dy, okay, that is still y. And then now that we are deriving, we say dy dx equals 2. So we drop the negative 1, we have negative 1x, 1 minus 1, it's minus 1 minus 1, it's minus 2. And then we have negative 3 times the negative 3 over 2 there, the exponent, that is going to be positive. I'm just going to do negative 3 times negative 3 over 2, that's positive 9 over 2. So we have positive 9 over 2x, and negative 3 over 2, negative 1, that is negative 5 over 2. So that is your final answer. You don't have to write anything as positive exponent because they did not request for that. So you keep your answer in this format. And then 6.2.2, find dy dx if y over x 3x equals to 1 plus x squared. So we have y, so this is for 6.2.2. sorry guys, with this a little bit of disorganization on my screen. So 6.2.2, y over 3x equals to 1 plus x squared. So I'm still keeping it as y over 3x equals 2. When we FOIL that, we're going to have x squared plus 2x plus 1. And then now we can, sorry, that is supposed to be a y. Now we can multiply with the 3x to get rid of the bracket. And also remember, you can only derive if your equation is y equals to something. If the y has a denominator of 3x, you want to get rid of that y because we want to make y the subject of the formula. So we have y equals to 3x x squared plus 2x plus 1, and y equals to 3x to the power of 3 plus 6x to the power of 2 plus 3x. Now we can say dy dx. Remember, you only do dy dx when what you will write after the equal sign is the derivative. So 3 times 3, that's 9x squared plus 12x plus 3. And that is our final answer for 6.2.2. Okay, so the derivative is h prime x is equals to 2ax minus bx minus 2 to the power minus 2. And they've given us an x of 2. So this x of 2 is like your x value when you have a gradient of 0, because we're talking about a minimum value, but also when you have your turning point. So here, when the gradient is 0, our x value is going to be 2 minus b minus 2 to the power negative 2. So 0 equals to 4a minus okay, that is supposed to be positive 2 minus b over 4. So 0 is going to be 16a minus b, therefore b equals to 16a. This is for us using the derivative, meaning we are saying when you derive at the minimum, because that is a positive parabola graph, at the local minimum or at the minimum value, meaning at the turning point. The turning point is 0, the x value is 2. And then now let us use the actual graph, because they say, remember, when you are working with the turning point, in a cubic graph, you do derivative, you equate it to 0, you solve for x, you take the x value, substitute it to the original equation to get the y value. So we do have a coordinate at the turning point. It's a 2 and a 12, meaning I can substitute that there and say when the y value at the turning point is 2, the x is 12, the x value is 2. So that gives us 2. That gives us 12 equals to a 2 to the power of 2 plus b over 2. So that's 12 equals to 4a plus b over 2, and that's 24. So I'm just going to bring a division line there so that we don't mix them around. So I'm multiplying, I'm getting rid of the denominator and multiplying everything by 2. 12 times 2 is 24, 4 times 2 is 8, and then plus b. So it means b there is going to be 24 minus 8a. So now, because we are solving for a and b, since we are looking at the same b there, I can equate 16a equals to 24 minus 8a. And 16 plus 8, that's going to be 24a equals to 24. And my a is 24 over 24, which is 1. And then b is going to be 16 times 1, and that is going to be 16. So a is 6, or a is 1, and b is 16. I hope that makes sense. I hope it makes so much sense, guys. So that is it with question 6.3. that is with 7 marks. 7 marks, 8 marks, there's gotta be some simultaneous. You're going to say, if we're talking about a minimum on a positive parabola graph, we are talking about a turning point. What do we know about a turning point? A turning point, you derive, you equate to 0, you solve for x. But when you derive at the turning point, what you get is the gradient, and the gradient at the turning point is 0, because the gradient will just be a horizontal line. So hence we substitute 0 and we put the 2 there, that 2. And then we also say that 12 and a 2 is a coordinate. Therefore, I can take it and substitute it on the original equation to say when y is 12, x is going to be 2. That creates our second equation. So that was our equation 1, and that was our equation 2. Then, because we are looking at the same b value, then you can say 16a is equals to 24 minus a, because they are both equals to b. Then we solve for a, and then we also use that to solve for b. Okay. I think we can now jump into question 7. With question 7, we have the graph of a cubic function f has a turning point at -1 and p, and b at a, -1 and p, and b 2 and q. The function f has the following properties. Okay, I hope you have jotted down that, guys, because I'm going to erase this part that is going away, because now we are going to sketch the graph of a cubic without the equation itself, but using the properties. So in order for you to use the properties of a graph, you are going to interpret each property. So firstly, they are giving us 2 turning points. One is at -1 and p, the other one is at 2 and q. We don't have p and q. Okay, it's fine. And they give us their properties. They say f prime x, meaning the first derivative, it's positive when x is less than 1 and when x is greater than 2. Meaning when x is less than this -1 there on the parabola, and when it's greater than the 2 there on the turning point, I mean not the parabola but the turning point, then the graph is increasing. So when they say f prime x means the gradient. The gradient is what? If it's greater than 0, it's increasing. So the gradient is increasing when x is less than -1 or when x is greater than 2. And then the gradient is decreasing. So now they say it's less than 0. So f prime x means gradient. Less than 0 means the gradient is what? Is decreasing. So the gradient is decreasing when x is between -1 and 2, meaning when x is greater than -1 and less than 2. So it means, what they mean here is, because we know the graph of a cubic can either be that or it can either be that. So if we have 2 turning points on the graph, for the first one, you can tell that when we are when x is less than this turning point, the graph is decreasing, and also when x is greater than this turning point, the graph is decreasing. And then when x is between those turning points, the graph is increasing. So it means f prime x there, it's greater than 0, there it's less than 0, and there it's less than 0. Is that what they said? They said f prime x is greater than 0 when x is less than, okay. Then let's check on this one. Let us check on that. I'm just gonna redraw this one again to say, okay, if we have that shape and we have one turning point there and the other turning point there, the graph is going to have, it's increasing there, meaning f prime x is greater than 0 there, and also f prime x is greater than 0 there. But between the two turning points, the graph is decreasing. F prime x is what? Is less than 0. Is that what they said? So they said f prime x is greater than 0 when x is less than the turning point. Why am I putting it like this? It shouldn't be, yeah, it's greater than 0 when x is less than -1, meaning x is less than the smallest turning point, and when x is greater than +2, when x is greater than the largest x value of the turning point. And f at x is less than 0 between -1 and 2, meaning between the two x values of the turning points, and we also have the same there. So that has helped us determine the what? The shape of the graph, to say the graph is going to be that one because that satisfies these properties. Okay, now at that we know the shape of the graph, but they also tell us that f at 2 is greater than 0. F at 2 is greater than 0. So what they're saying is we have a coordinate when x is 2, the y value there, it's going to be maybe 3 or 4 or 5, any value that is greater than 2. So that is what the coordinate means. So now they say draw a neat sketch of f, clearly label points A and B on the sketch, and it is not necessary to show x and y intercept. So I'm just gonna put my Cartesian plane there. Already we have the shape of the graph. I'm gonna label our turning points because they said one is at -1, then the other one is at 2. And then they said it's because we have a local maximum and a local minimum. It means the first turning point is going to be there, and then we now have to decide, because the second turning point is at 2, but they had said that when it is at 2, the y coordinate is greater than 2. So it means it's not exactly at 2 and 0, it's somewhere above 2 and 0. So the graph is going to go something like this. It crosses there, then it crosses the second turning point, and then it goes like that. So that is our graph. We don't have to show any turning points. They said we must only show A and B. So that is going to be A, and it's -1 and P, and that is going to be B, and that's 2 and Q. Then we are done. 4 marks. We have the 4 marks. That's how you're going to use properties. You're going to interpret and say, when they say f prime x is greater than 0, they actually mean that the gradient is increasing when x is less than -1 and x is greater than 2. And -1 and 2 are the x-intercepts of the what? Of the turning points. So make a graph, make 2 graphs and see which one is going to satisfy these. F at x is less than 0. It's decreasing. The gradient is decreasing when x is between -1 and 2. So that one failed. We are taking that one. Okay. And then let us look at 7.2. 7.2, they say if f at x is x cubed plus b x squared plus cx plus d, calculate the values of b and c. So we are still using that graph, the graph that we've just drawn, to find b and c. Okay, so we have, what do we have on our graph? On our graph we have turning points. So now, if you had watched the previous video, you know how it works when you have a turning point. How can you find the equation of the graph? So if you have a turning point, you're going to first do first derivative, because turning point is related to f prime x. So that's going to be 3x squared plus 2bx plus c. And then that you're going to first substitute, because it's 6 marks, meaning yes, there's gotta be some simultaneous. You're going to substitute -1. You don't have to put the p, because at the turning point, that is the gradient, it's gonna be 0. Then you're also going to substitute 2 and q, but q still you're not putting it. So at the turning point, because a turning point, the gradient is horizontal and the gradient of the horizontal is 0, and we had said that is a gradient, I'm going to put 0, and then where we see x, I put -1 squared plus 2b -1 plus c. So 0, it's going to be 3 minus 2b plus c, and c would be equals to 2b minus 3. That would make what would be my first equation. I'm going to do the same for 2 and q. Still, I'm using the same derivative, and I say 0 equals to 3 2 squared plus 2b2 plus c, and 0 would be now equals to 3 2 squared, so that is 3 times 4, that's 12 plus 4b plus c, and c would be minus 12 minus 4b. So that is my second equation. But because we are equating them to the same c, it means they are equal themselves. So 2b minus 3 equals to -12 -4b, and 2b plus 4b would be -12 plus 3, and 6b is -12 plus 3, that's -9. So b would be -9 over 6, and that is that is supposed to be a 6, not a 3, and that is going to be -3 over 2. That is our b. And then to find c, we substitute -3 over 2, so that's 2b minus 3. Then we put b, there's going to be 2 -3 over 2 minus 3, and that is -3 minus 3, and our c is -6. There we have it. I hope you're still following along, guys. Whenever you have to find the equation of a cubic graph, or whenever you have to find a, b, c, or d, check what you have. If you have turning points, 2 of them, that's a package. You derive, you substitute the first turning point, you will have 2 unknowns. Then you substitute the second turning point, you have 2 unknowns. Then you solve simultaneously to get the 2 values that they're looking for. Okay, I hope you have this down. I hope it makes sense. If you want to take a picture or a screenshot, I will just zoom it to fit the screen, and then you are able to take a screenshot. Okay, next question. Question 8. Application of calculus. Optimization of calculus. During an experiment, the temperature T in degrees Celsius varies with time T in hours. According to the formula, T of T equals to 30 plus 4T minus a half T squared, where T is an element of 0 to 10. So they give us an equation that represents the temperature and time, and it looks like it is a parabola or a quadratic equation. And the first question, determine an expression for the rate of change with time. So in optimization, or in application of calculus, rate of change means you derive. We want the derivative. And then if they want an expression, you just leave it as an expression. So our normal or our original equation is 30 plus 4t minus 1 over 2t squared. And then now the rate of change, I'll just do t prime time. The derivative of a constant is 0. Derivative of 4t is just 4. Then the derivative of negative a half t squared, negative a half times 2, that is negative 1t. So our derivative is 4 minus t. That is the rate of change. And then 8.2, that is for 8.1. 8.2, during which time interval was the temperature decreasing? So when I think about this question, or when I see decreasing, I'm now thinking about it in terms of a parabola, because we have a quadratic equation. And if you look at the quadratic equation, if I am to rewrite it like in the format, it will be negative 1 over 2t squared plus 4t plus 30, meaning we have a negative parabola. And a negative parabola, they also set the t, so it means the t represents the x-axis. The t must be between 0 and 10. So it means we are only considering the values 0 and 10. And then the graph is increasing when t is less than the turning point. It's decreasing when t is greater than the turning point. So it means we need to find the turning point, meaning the x value there at the turning point, because it's going to represent the time. So I can use x is equals to negative b over 2a, but I'm going to say x is t because we are not using f at x, we are using t of t, yeah, not the t but the t of t. 2a, and then my b is 4, so that's negative 4 over 2. My 1 is negative a half, and that would give me just gonna quickly plug it on my calculator. 2 negative 1 over 2, that gives me 4. So it means the turning point that the x value is 4. And remember, we are saying the graph is between 0 and 10. So it means because we want the interval where the temperature was decreasing, we're going to say the temperature was decreasing because we know the last point after the turning point is 10, and then the smallest is 0, because the graph must exist only between those times. So the interval would be t must be greater than or less than 4. No, yeah, it must be less than or equals to 4. It must be great. It must be. What am I saying? So the interval is t must be greater than or equals to 4, less than or equals to 10. That is where the graph, the temperature would be decreasing, and that is the final answer. Or you can use the derivative, guys. I'm gonna use the alternative method, because when we say decreasing or increasing, we are saying when you draw a straight line, we want the gradient to increase or the gradient to decrease. We already have the rate of change. This represents rate of change, it represents gradient. So this graph, when it says temperature was decreasing, we mean when t prime t is less than 0, less than or equals to 0. And then that is 4 minus t is less than or equals to 0, minus t is less than or equals to 0, not 0 but 4, minus t is less than or equals to minus 4, and then t, it's because we divide both sides by negative, the inequality changes. T must be greater than 4, but because the inequality, they specified that the interval to be 0 and 10, we cannot say greater than 4. We are going to say for t to be, yes, greater than or equals to 4, but it must be less than or equals to 10, because we are only using 0 and 10 intervals. That is the final answer. Thank you, guys. I hope this is going to help you. Please guys, for tomorrow, don't make silly mistakes for calculus. For those who are writing tomorrow, please read the question and apply what you have learned about calculus. If you feel like you don't have enough, or you need more revision, go through the videos that I've posted on my YouTube, have a look at them, watch them, look at the examples that we've done, and trust me, tomorrow it's gonna be much more easier for you. Thank you so much for watching.